right now, and I'm going to go over some tools real quick, and then out to the shop make some parts. Okay. We've gone over the lathe a little bit, but what I want to show you are some tools for the lathe. This is called high-speed steel, okay, and it's like a just a blank. And what happens is this profile up here is ground in with a grinder, and then dressed a little bit with a stone. So we'll try. You can see that shiny area around. There's a little radius right in there. Okay, that's put in with a stone. And then all this profiles and what are called rakes and reliefs and all that, which we're not going to talk about, are ground in on a grinder. I make them, okay? I'm going to show you a lot more in a minute, and they're all tools I've ground, okay? Once again, it's called high-speed steel. And it's abbreviated HSS, okay? You're going to be seeing a lot of those. I'll probably even grind a couple on camera maybe in the future semester. But what we need to know is, here's our chuck, okay? And it's holding a piece of material in the lathe, right? It's sticking out, right? Okay. When we use this, we typically, just like everything else in machine shop land, typically we cut with the tip. Okay, so let me draw that. And what I mean by the tip is that had a profile like that, all right? So we're going to try and cut with the tip. Okay, we're not going to cut with the flat, like this whole flat. Sometimes you do. But right now, okay, we're not, okay? Just like everything else in machine shop, I mean, there are techniques and it's endless, right? I keep saying that. But for the most part, we're just gonna cut with the tip, okay? Just a little bit, all right? Let's see here. Now, it's tough. Okay. The spindle, the formula, the spindle speed formula, is for the rotation here of the chuck. Okay. But that doesn't always go as like you don't run that formula. So if this is 2 inches, okay, and you run that formula 2 inches. And then set your spindle speed to that formula, well, the diameter is changing. You're machining the diameter. So the diameter is constantly changing. And if we look at this on the front view, if we're facing, so there's not three, I take that totally back. Machining off this face here, running the tool along here, okay, that's called facing. It's called facing. Facing. That's that. If we run the tool along the diameter here, okay, that's called turning. So what happens and why that spindle speed formula doesn't always work out so well is that if we draw front view of our circle, right, and we're facing, the diameter is going from 2 inches, we're facing, to 0. Okay? So we find a nice happy medium on the lathe, okay? And that's another reason why the lathe is so cool, is because it's so forgiving. Unlike the mill, you've got to run that spindle speed formula on the mill, all right? You have to, or you will, it will not be fun, okay? But on the lathe, we don't always need to do that, all right? So that's enough of that, okay. So, I want to go over some different types of tooling and a couple other operations, and then we'll go out to the shop. This is your basic tool, okay? High-speed steel, ground this profile, all right? This is textbook right here. Now, there's other types. This is another one that I've ground. I wouldn't say this is the best profile, but if you look closely, it has this little ground relief in there. That's called a chip breaker. So it helps, you know, you're going to see when we machine, we develop these chips, and sometimes they're long strings and they create a bird's nest. These chip breakers help. Not all the time. It depends on your depth of cut and your feeds and all that, okay? Sometimes they work great, sometimes they don't. That's another tool I've ground. This actually works really nice for aluminum, and it needs to be touched up, I can see looking at it now. Okay. More high-speed steel I'm going to show you before we move on. This is a parting tool that is in really bad shape. Okay, this is a parting tool, okay? And what a parting tool does, it can do a few things. So it's going to go in your material like this. Now, what it's going to do is it can either part off, right? So we can run this in, okay? And when we reach half of the way of the diameter here, it's going to fall off, okay? The part it off. We can also cut a groove. So if this is the material, okay, we could run this parting tool in here and we could cut a groove, however deep we want. We could cut a series of grooves. I mean, okay? This is what's called a parting tool or a grooving tool. Okay? This is in pretty rough shape. Before we move on here, this is a very tiny boring bar. Okay? And what a boring bar does is it will... So we have an OD. Some of you are like, I already know, I don't have to draw it. I'm going to do it anyway. We have an outside diameter, okay? We can also machine an inside diameter. And it's very similar to turning, okay? Except we are going to be using this tool to get in there, right? Okay? It's not as stiff as turning. So there are some things you need to know, okay? And I'm going to demonstrate, we're going to go slow. All right, so those are some very basic high-speed steel tools. They can be ground into any shape. So before I move into the carbide, let me show you a couple other ones, okay? This is a forming tool that I've ground. I don't remember the exact radius of it, but see this radius right here, okay? What this tool does is exactly that, is exactly what it looks like it does. It is going to machine in a radius. So if this was my part, this tool, the very first one I showed you, right? If I were to machine that in, it's going to leave me a sharp corner, okay? Hence its profile. This tool allows you to machine in a radius, okay, into that corner. But there's a lot more surface contact. Remember I told you you have to cut with the tip? Well, this doesn't cut with the tip. So it chatters like crazy. You got to slow down the spindle speed a lot later. We're going to do that later. Okay? The other one I wanted to show you is this. This I've ground. It's high-speed steel too, all right? And this, let me look, yes, this is just, it's about 80 thousandths in width, okay? And what this tool is for is, what I was able to do is, here's my bore, right, section view, right, okay? I was able to take this tool and come in here and put a little 80 thousandths groove in here for a little clip. So a clip went in there, okay? And so that was ground out of a big piece of high-speed steel. Okay, I didn't grind the whole thing. I found a box of tools, a big box of ground high-speed steel. I don't know, maybe 20 or 30 years old. And I emptied the box in my drawer. And when I need a tool, I'll just grab one that's close, you know, and that's probably not ground so well, and I'll touch it up and fix it, and saves myself a lot of time. All right. So moving on here. This is a cemented carbide, okay? So what's going on here is that this, like the high-speed steel blank, it's probably not high-speed steel, it's probably mild steel, but it has some carbide cemented into it, or brazed. I'm not going to get into what brazing is, okay? This cemented carbide, I know we need to talk about carbide, is bought in this profile, and this needs to be touched up a little bit too, okay? These are great. They're really great, but modern manufacturing has moved into this type of tool, okay? Now you're like, whoa, what's that? Okay, this is called indexable carbide. I was going to write it. Indexable, I'll put it under this. It's indexable carbide, okay? So this insert, that's what it's called, is made out of carbide, this little unscrews this clamp right here, and you can take it in and out. This particular one, I can take it, and when this tip gets dull, I take it out, and I just flip it around, and there's a new tip on the other side of the diamond, okay? I got another one here. I'll show you in a minute. But what I want to talk about is carbide. Why have we moved to carbide? Carbide. There's lots of reasons, okay? Whoops, that's a D. Carbide, okay? Okay, so carbide is significantly harder. Well, I'm not going to say stronger, okay, because it's brittle. But it's significantly harder than high-speed steel. I don't know exactly how much, but a lot, okay? It's so much harder that when you have coolant, like in a CNC machine and an automated machine, you can triple your feeds and your speeds. What's that mean? I triple the RPM, I can triple my feed rate that I'm only telling you is slow, so now it's going medium, right? The part comes out 3 times as fast. And in manufacturing land, that's a big deal. It's a huge deal. Time is money, okay? So these carbide has enabled, especially with metals like aluminum and mild steel, to really increase production, okay? There are some drawbacks. But first, they also are great in the manual shop too. They're great for working with really hard metals, okay? They're more advanced machining. That's why I'm like kind of pulling myself back, okay? We're gonna use carbide a lot. The turntable we're gonna make is a lot of stainless steel, and so I'm gonna use carbide.
The demo that we're going to see in just a moment is going to use carbide too, okay? And I'm not going to talk too much more about it. Here's a carbide, an indexable carbide boring bar, okay? And you can see that this particular insert has 3 corners. So as this gets dull, which it is pretty much, it's got a little bit of life left in it, I can unscrew this and turn it. And I've got 3 tries. Now there's some that are really cool. And the triangles, I don't want to get into the geometry of the tools right now, okay? It's like next class. It would be machine shop 1650, I don't know, okay? So, but some of them are triangles. And when they're triangles, they have 6 sides. So we've seen the first one, that diamond, actually has, you grab it, it actually has 4 sides to it. It has 1, 2, and I flip it over, 3, 4, okay? So that's 4 sides. This boring bar, oh, yeah, I thought it only had 3. This boring bar has 6 sides to it too, okay? Sorry, I'm talking, okay? And so it has, I don't even need to draw the triangle. It has 1, 2, 3, and then you can flip it over and it has 6 sides. The other reason that the carbide's so cool is, you guys, grinding these tools takes practice, okay? It takes a lot of practice. You just don't walk up to the grinder and grind one of these out. So in manufacturing world, the laborer, yeah, I'm just gonna, yeah, you're gonna have to pay the person, the skilled worker, a lot more money to grind tools. Paying money takes a long time. The carbide's the way to go, okay? But the inserts are expensive. I think that just about does it. We're gonna see, I'm not gonna really get crazy into this because we're gonna see all this in action on the machine. Yes, for doing threads, I don't have one, I didn't bring one, but you grind a tool, the profile of the threads. So it was gosh, you have your thread profile, right? And you have a tool that's ground to that profile and it cuts that profile of the thread. All right? Okay. So let's go out to the lathe. All right, so what we're gonna do for the next few minutes is we're just gonna go over the lathe. It's really actually pretty simple, and like I've mentioned a few times already, it's just awesome. I'm going to show you a couple parts that with names and stuff like that, but mostly I'm just going to show you how it's run. Just like before on the vertical mill, you'll see all these levers and cranks and knobs, and really once I break it down, it's super simple. Okay. So really, don't be intimidated by the knobs and the levers. Actually, most of them are just either charts or direction. Okay, but probably one of the most important things to go over first is this device right here. This is called a tool post, okay? And what happens is your tool that we talked about is the tool, which is this piece of high-speed steel right here, and it's in the tool holder, okay? And this is the tool post. So this is called a dovetail for obvious reasons. It's, you know, right? It looks like a dovetail, not, you know, kinda. All right, and your tool drops in here, and then this lever comes down and locks it in place, okay? What is important though is that the tool, it's the tip of the tool, remember we cut with the tip of the tool, is on center, on the center axis of the chuck or the spindle, okay? The way that is accomplished is through this little set screw right here. Okay, so you can see these set screws. Okay, and what you do is you put an Allen wrench in here. Is that the wrong wrench? That's the wrong wrench. You put an Allen wrench in here, and you can make this set screw go up or down. That set screw rides on this little post back here. See this pin sticking out? Okay, so that set screw rides on that post, and by turning the set screw in, the tool is going to raise, and by undoing it, okay, raising the set screw in here, it's going to lower the tool holder, okay, thus lowering the tip of the tool. And then that, right, locks it in, okay? That's that arrangement, okay? Oh, almost forgot. The tool post, to be able to cut with the tip of the tool, you can rotate it, okay, and then just snug it up. Notice I said snug, not crank on. No need to crank on it. Snug up this machine screw right here, okay? And that'll snug up the tool post. This back here is called the tailstock. I don't want you to worry about it right now, okay? It moves back and forth. This is the center. Don't even worry about it right now. We will use it, but don't worry about it right now. This is the chuck. This is a 3-jaw chuck. Though you've seen the lathe we're going to be using a lot. This lathe has a 4-jaw chuck in it. Okay, now let's start with the 3-jaw. The 3-jaw chuck has 3 jaws, and you can't see it, but inside the chuck is a scroll. Okay, so when you take this chuck key and you tighten the chuck, all 3 jaws move in together, all right? Or if you loosen it, okay, undo it, the jaws are moving out. Currently, the way I run my 3-jaw chucks is with soft jaws. So I make these aluminum jaws, and I put them on here, and then what I'm able to do is actually machine my jaws, so everything runs really nice and concentric, and I can take parts in and out, because here at school I got to be quick. There's not a lot of time necessarily sometimes for me to be centering things and indicating things in here and there. And I'd say, you know, honestly, maybe 50% of it doesn't even need to be that accurate. However, when I machine these jaws, I can take parts in and out, and they're within a thou. Okay. I have to, they don't hold up forever. I got to machine them all the time. Not all the time. A little bit of the, you know, maybe once a week I take off 10,000ths on them or something. And then, yeah, when they are done, they're done. I throw them, put them in the recycle bin, and I make 3 more. Okay. So that's the 3-jaw chuck. I'll show you the other chucks later. Let's just continue moving on with the lathe, okay? And then a quick demo. So, we've already seen some of this. The carriage, right? This wheel moves side to side. This wheel moves the carriage back and forth. This is called the compound rest, and it will move at any angle. I can move the whole rest, and then I can, right? I can move it in and out. So I can cut like an angle. So like I could cut like a 45-degree angle on this, or any angle degree that I want, really, all right? And let's see, I like to leave it at 0, that way I know if I bumped it or not. Okay, let me see. This is a tool. I made this just like the one we already made, okay? It's just you can tell it's indicators. We got a new well, not new, but we got a fresh indicator. This one is being used. All right, to turn the lathe on or off, I'm gonna put this in here, this piece of aluminum in here. I don't like to run the lathe on and off without something in the chuck. All right, so to turn the lathe on and off are these this lever right here. And you can see the other one moving too down there. See that down there? Okay. It's because they're attached together on this bar. Okay. The lower of the 3 rods or bars. Okay. And so up, let's get it in gear. And don't worry, we're going to go over this in just a second. Right? Now we're on, okay, and we're off. And then if I pull this lever up, I'm going counterclockwise. If I push the lever down, I'm going clockwise. 99% of the time, you're going to be going counterclockwise. Why? Because we want the material to come down onto our cutting edge, okay, on our tool. Now, we'll talk more about that in a second too. But let's go over here to, this is the on and off, okay, to what's going on over here. All right. You guys, this is really simple. Super simple, all right? This is just a chart. This chart here, these two levers, and these 12 positions that it has, tells you what speed, what RPM the spindle is going to be running at, okay? So the chuck is attached to the spindle. Currently, I'm in 351 because this lever is in this, well, I know it's dirty, but white, okay? And then this lever is in this column here. So it's white and it's 351. If I move this to red and I'm in this column, what is it? I'm in 95. If I'm in red and I move this over here, I'm in 132. If I move this over to blue, I'm in 1800. I never use 1800. That's just super fast. But you know what I use every day is 650. All right. That's it. So it's just a chart. So is this. The 1, 2, 3 is just a chart. I know it's dirty. I tried to clean it up. That's as clean as it will get for right now. So this will move into any one of these columns, okay? And this chart is divided up actually into two charts. And it says fine and coarse. And up here, we can see this lever selects what chart, fine or coarse. So we're in fine. So we are in this, right? Because see this lever here is in this column, okay? And then down here, I've got C, B, or A. C, B, or A. Well, I'm in C right now. So it's telling me that I'm 176. 176 what? Threads per inch. We know what that is. So quarter 20, right? There's 20. 1032, there's 32, right? 32 threads per inch. But you know what we want to know more about? It says threads per inch and feeds. We want to know about our feed rate, okay? So if I move this to A, now I'm in 44, okay? And this little tiny number down here says 0.0095. Let's just, for simplicity's sake, let's just call that 9 thousandths, all right? So 0.009. That means that when I engage the power feed, the carriage is going to be moving at 9 thousandths of an inch per 1 revolution, all right? I don't want you guys to worry about it. I'm just explaining what this is. We're still going to be going off of fast and slow, okay? So if I move this lever over here into this far column, I have A, fast, B, medium, C, slow. Why do I know that? Because it says 13 thousandths per revolution, 6 thousandths per revolution, which is basically half of that, and then another half of that, 3 thousandths per revolution, okay? So I've got fast, medium, slow. To engage the power feed, I use this lever here, okay? So if I move this lever up like this, the carriage will move this way or that way, okay? If I pull this out and down, The cross slide is going to move back and forth, okay? There is no power feed for the compound rest, okay? Now, what direction, when I move this lever, if I want to power feed and move the lever from whichever way, this lever right here selects that direction, okay? So if I'm in this direction, we'll see which way it goes. If I'm in this direction, it'll go a certain way. This lever right here and this dial, this device, this is for threading. Don't even worry about it until we thread. Ignore it. Pretend it's not even there. Guess what? We're done. We're done. There's no more to go over. Okay? Well, there is a little bit, but for the most part, we're done. I've selected my spindle speed. My material's in here. It's going to go at 650 RPM. Okay? I've got my power feed set up. Fine. Okay? I'm in this, right? This column. And then this lever right here selects if my power feed's going to go fast or slow. That's simple. This is the direction of the power feed. Okay? Let's give you an example. So let's turn this on. All right? That's kind of wobbling on me. It's all right. I'll fix it in a sec. If I move this up, if I pull this handle up, it's going this way. Okay, so if I have to turn off the machine, all right? And if I switch this lever this way, now it's going that way, okay? And if I go out and down, the cross slide's coming this way. And you guessed it, if I flip the lever, the cross slide's gonna go that way, okay? It's really simple. So let's check this out, and there's a couple safety things I need to talk about. I wonder why this isn't running so good right now. I probably need to machine my jaws a little. Let's see. Put that back in. Let's see. Actually, it's not running that bad. We're getting an illusion. Yeah, okay. The face is crooked, so we're getting a bit of illusion. I can tell because of the light. All right, anyhow. Okay, so let's make a quick cut. Let's face this, okay? And so we're gonna be using the tip of the tool. Oh, first we have to get the right height. A good way to get the right height, kind of cheating, and you still have to adjust it afterwards. You're not done, by the way. This is just a way to get going. I turn the tool post over here, and I bring this, what they call a live center, out a little, okay? And I can just sort of eyeball this and see, well, I'm pretty on. I'm pretty good. And we can get it close. And later on, not today, but later on we will see me make quite a bit of adjustments on that, all right? So you can see I just moved the tool out, so I'm cutting with the tip of the tool. Just the tip, not the sides, you guys, the tip of the tool. I want to cut with the tip of the tool right now. And so I'm just going to do this by hand, no power feed. Okay, the first thing I'm going to do is what's called a touch off. So I'm just going to touch it. Okay, very lightly. Okay, and then I'm just going to dive in a little on the carriage. Just a little, see that? Just a little bump. And I'm going to go ahead, and you can see now I'm cutting. Okay? This particular tool will cut both directions, I think. Actually, it likes to cut probably towards me better. So I'm going to do that again. Let's touch off. Okay, we just touched off. Bring the tool off the part. Dive in a little bit. And I'm just, that's my feed rate. See the hand, right? Okay. Okay. Now, That was called facing. Half bad. Finish, that is. Let's do along this way, okay? And that's called turning. And in order to do that, I need to adjust my angle, right? Because see, I was like this before, and it would cut with the area that's not even ground. So I need to adjust my tool angle. So I'm cutting with the tip. I like that there, okay? And I'm gonna do exactly the same thing, only now I'm gonna be turning instead of facing. So I'm gonna bring the cross slide back over. I'm gonna come in here, and I'm gonna literally do the same thing. I'm gonna touch off, okay? And so I'm gonna turn it on. And I don't know if you can see this on camera, but this is not wobbling very much. It's out a few thou. This is real bad, the part that's been machined. So what we're gonna do is kind of true this up. And now, remember, I'm doing this by hand here, so you can see my feed rate. And then I'll show you the power feed, okay? Okay. So let's get rid of the chips. Let's do another one by hand. Okay, so I'm gonna touch off. Bring the tool off the part, and then I'm just gonna go dive in a little bit here, okay? Like 20 thousandths. I know I haven't even shown you the dial, the numbers on the dial or anything. They're the same as the mill. All right. Okay, I'm just doing this by hand. All right. Let's use the power feed. So I'm just gonna go in, I don't know, I went in 30 thousandths of an inch, okay? Now I'm gonna engage the power feed. Turn it off, finish by hand, because I don't want to crash, okay? All right, so speaking of crashing and things of that nature, believe it or not, the lathe is pretty safe. Common sense, obviously. The biggest thing that people do, especially students, is they leave the chuck key in the chuck and then turn it on, okay? All right, so the rule is, and I follow this, is the chuck key is either out of, not being used and completely out of the way, or your hand is on it and being used, okay, to put your material in and out of the chuck. If it's not, right, when it's in your hand, it's being used. When it's not in your hand, it's not being used. Okay. I don't want to scare you, but I want to tell you there's this chuck. When you turn the machine on with the chuck key in here, obviously I'm not going to do it, right? One of three things are going to happen. Seriously, okay? First thing, and the most probable, is that this is going to come, and it's going to come crashing down, okay? And things are going to break. And it's going to be really, really, really loud. It's going to scare the daylights out of you, and you're going to break stuff, and it's going to ruin the machine, okay? That's what's most likely going to happen. The second most likely thing that's going to happen is you're going to leave the chuck key in here. You're going to go ahead and see where I'm standing. I am directly in line with this chuck key. You're going to turn it on, the machine on, down here, right? Where is this chuck key going to go? It's going to hit you right in the ribs, okay? And then you are going to go hit the floor instantaneously. And you're going to have the wind knocked out of you. You might have a broken rib, and it's not going to be fun. How do I know? Yep. I've been doing this a really long time. And yes, I've had the chuck key come out, hit me in the chest. I hit the floor. And if anyone's had the wind knocked out of you, that's what happens. I have also crashed the machine Not this particular one, although it has been done before. I have crashed a machine. I left the chuck key in, and it comes barreling down and scares the daylights out of you, and then you do damage. The third thing that can happen is the chuck key is going to go flying off that direction. And then if someone's over there, it could hit them. So this is the main safety concern, okay? Don't leave the chuck key in the chuck. That's awful. Now, there are lots of rotating things on this, okay? These two, this screw right here and this bar, they're rotating. Let's see, am I gonna crash? No. So that's rotating, okay? This is just not engaged, but often this lead screw, what's called a lead screw, is rotating too. So if you've got your shirt tail, you know, you can have your button-down shirt not tucked in, and it gets caught in there, okay? That's bad news. Necklaces, sweatshirts, sweatshirt strings, right, that are on your hoodies, okay? We are all very tempted to look closely at what's going on, okay? Long hair, I don't think I need to tell you. This thing's rotating. It's gonna catch all that stuff. You gotta tie up your hair. You have to tie up your hair. You can't have a ponytail, because what happens with the ponytail, right? It's hanging over your shoulder. These machines are not gonna stop because they think, oh, there's someone's hair is getting in the way. No, all right? When we're in actual lab setting, we will go way more about that, but no loose anything ever. It's in the syllabus. It's pretty obvious, I think, at this point, okay? So there's the main safety stuff. Chips, we'll get there too. We don't want to be touching chips, especially steel ones, with our bare hands. They'll just cut you. They're razor blades. There's quite a few things. You don't want to take measurements with the machine on. You don't want to, you know, but we'll get there. Okay. So there it is. Facing and turning. So what we're going to do now is we are going to make a part. We are going to face, turn, knurl. We're going to bore and part our apart. Okay. And awesome. All right. So we'll get on that right now. All right. Okay. All right. So here's the part. Yes, I know this is very confusing looking. But what's going on here is we're gonna do this on the lathe. First of all, there are some times in the machine shop, actually a lot of times in the machine shop, I'll get a part, I don't even know what it's for or anything like that, all right? So I just make it. This is for a process called lapping. We're gonna do lapping, so you're gonna understand what that is, but I'm not gonna explain that right now, okay? The video will just get too long, and I don't wanna do that to you. So we're gonna make the tool for lapping, and some of you might be saying, God, Blake, we've just been making lots of tools. Yep, I know. I like to make my own tools and not buy them. And these are tools we're gonna need for the record player, the turntable. Plus they're tools that I'll have for, if not the rest of my life, for a really long time. Okay, so anyway, what this is for lapping. And what it's got in here is, these are two I've made. This one, I kind of just made on the fly, and the edges in here, like this, where there's metal left right around here, it's too thin. I wasn't happy with this, so that was scrap, but I saved it to show you. And then here's another one that I did, and the way this works is it's got this aluminum insert in here that I make, and then there's this screw right here, and this screw goes in here, and you can see that it tightens up this diameter. So this aluminum insert has a slit in it too. And so as you tighten this screw, the diameter gets smaller, and all these slits and holes are kind of designed to make this close evenly, to try and keep a circle, all right? I think this one will work, I think. Yeah, but I also realized, I said, you know what, let's try something else too. And I want to make one more, plus on this one, I botched the knurling. I don't know how that's knurling, the diamond pattern in here. This one I got, but I don't know what happened. This one got botched. Anyway, okay, so I want to do this. We're going to use the lathe to be a great introduction to the lathe. Where we're gonna put a piece of steel in the chuck, and we're gonna face it. It'll be in the machine like this, right? We're gonna face it. We're gonna turn it, and we're gonna bore it. Okay. The rest of these holes are done on the mill, and I'll see how long the video gets. Maybe we'll get to that, maybe we won't, all right? I'm not too worried about it. What I want to do is the lathe, but here's the interesting part about this part. Aha. This circle in the center, the bore, the inner diameter is not concentric to the outside, okay? And it's actually, when I designed the part in SolidWorks, I moved the concentricity, so it's, I guess that's eccentric, 100 thousandths over, okay? So we're gonna do that. We're gonna move the part over about 100 thousandths and bore out this hole non-concentric, I think. Okay, so let's, oh, a couple more things. I know the drawing is very confusing. It's sort of just so I can make this part without having to look at the computer and stuff. This probably isn't the best example of a drawing, although you can make the part from the drawing, and that is what we need to do. When I dimension this, I didn't go in and like edit the dimension. It says radius is 688. That's because the circle, the inner bore is broken right here, okay? So 0.6875 is the actual number there, times 2 is 1.375. So we've got an inner diameter of 1.375. We've got a outer diameter of 2.5. We can see that here. A depth, the part should be 1 3/4 or 1.75. And then it's got knurl around it, all right? So let's head on over to the lathe and see what we can do, okay? All right, so here's our material. It's some steel. I don't know the alloy of the steel. I just found it, okay? So it could be a surprise. It could be real easy to machine, or it could be an absolute nightmare. So we're gonna find out. But what we need to do is we are gonna put this into the 4-jaw chuck, okay? Now, the 4-jaw chuck, unlike the 3-jaw chuck, each jaw is independent, okay? So when I turn each jaw with the chuck key, okay, each jaw moves independent. And what I'm gonna do is I'm gonna be able to use an indicator, a dial indicator, and make the part perfectly concentric to the lathe, okay? This particular 4-jaw chuck is actually kind of special. It has a scroll in it, all right? And what you can do, and I might go over this again because we're gonna be using it so much, is, make sure my camera's in good shape, yeah, is each jaw, get this out here, each jaw has a detent. So it just popped into that detent, okay? Each jaw has a detent. And what that does is help get the lathe aligned. The chuck aligned. Another thing I want to talk about is the compressed air. technically you're really not supposed to use compressed air, and the reason you're not, well, not only do the chips fly around, okay, but you're pushing the chips back into the chuck, which is bad. But in the real world, we use compressed air, okay? So you guys in lab are not gonna use compressed air very much, all right? But down here, and like I've already said a few times, this is kind of a real world class this semester. So yeah, I'm using compressed air. So first, let's get this going here. So this is on a scroll, right? It's a 4-jaw on a scroll. So I can get this started on the scroll. Let's get this in here. And then I can indicate in my part and move each jaw independently, which you'll see right about now. All right, so what I need to do though is make sure that I have enough area on my part to work in. So the part's 1 3/4, okay? 1 3/4, so it's right about there. That should be enough so I don't crash into the jaws, all right? So, lightly, I have put this in the 4-jaw, just very lightly, okay? All right. Watch this. This is, let me get this situated a little better. All right. This is a dial indicator on a magnetic base. And so if I put this magnetic base, right, on the tool post, I can align this, move this around sort of like this and get it nice and sturdy. Okay. And I'm gonna move the cross slide in, right, until I touch the plunger on the indicator, and then I'm going to preload it a little bit. All right. So I preloaded it on, it just happens to be on 0, okay? Now as I turn this, we can see there's a little nip there. I'm gonna do something first here. So I'm gonna snug this up so it doesn't fall out. I want to be in about 265. So that looks pretty good. And let's see, we're gonna see that it's gonna be really out of round, okay? It's not that bad at all, actually. What I want to do, I want to clean this up just a little so I can get a good run on that indicator and get some of this rust off of here. This is just some Scotch-Brite. So guys, safety tip, big time, never use a rag. Never use a rag with the machine on, all right? If that thing gets caught in here, it can be very, very dangerous. Never use a rag with the machine on. All right, so let's make contact again. And once again, I'm moving, I have the magnetic base on the tool post and I'm moving the cross slide, okay? And what I'm gonna do is make contact and just preload it a little bit, the indicator. And I'm just putting it on 0, not because it has to be, but because it's just easier to do. Now you can see, I'm actually really good here. I'm only, let's see, that's 3 low. Okay, so the indicator's, going that direction, so it's low, and then it's increasing here, moving to the right, and I'm about 4 thousandths high. So what I'm going to do is on each independent jaw, I'm just going to lightly get this balanced in here. And that's all it is. It's a balancing act. I'm finding the high spots and moving it over. And then at the same time, it's getting snugged up in the lathe. And now you can see that I'm about 1 thou out, right, on the indicator. And let's see, I can maybe even get it even better than 1 thou. That's pretty good. Okay. So yeah, that scroll really helps. Okay, so that's a 1/2 thousandths out, all right? So we're in. Okay, now when I turn on the lathe, you're gonna see it's running a lot more true, okay? So, okay, we are ready. So I don't know what type of material this is, so I am going to hit this with carbide first. And let's see how it goes. And if it seems to go pretty good, I might switch off to high-speed steel. But let's see what happens, okay? With carbide, I'm gonna run a little bit faster. So I'm gonna run the speed up, okay? And remember, we wanna cut with the tip. We already are cutting with the tip, probably because I was facing before. So we'll just bring this around and we'll face it. And so I'm gonna touch off. Yeah, this is good. It's pretty hard. It's not too bad. It's harder than I thought. I still think we'll be okay. Okay. Which way am I going here? Okay. So, the power feed on there. And let's see how that looks. Not too bad. All right, so this is pretty sticky stuff. I'm gonna slow this down. I'm gonna slow the power feed down a little, and just going to take about 10 thousandths here. Okay, let's see. I'm not crazy about that finish. So what I'm gonna do, is my insert messed up? Insert might be a little old. I'm gonna speed it up a little bit more. I know, I always say slow down, but this is carbide, so the rules are a little different. Let's see how that behaves. Yeah, that's a lot better. Okay. All right. That's okay. That's not fantastic. Insert might have a chip in it. And this. So what I'm going to do is I had some problems. I'm going to swap inserts here. And I can just see this insert is seeing its last days. I'm going to regrind it. Maybe get, a few more hours out of it. This insert's bad shape too. I'm kind of trying to use up everything in case anyone's wondering what's going on. I don't know. I probably shouldn't do this for class. but that's what I'm doing. And so we'll get this in here like that. This around here. And it looks pretty good. Okay. Let's see how this behaves. Touch off. Yeah, I can already tell. I think that's a lot better. Not fantastic, but it's a lot better. Yeah, that's a lot better. All right, so we have this faced, okay, and now what we're gonna do is change our tool angle, and we're gonna turn, okay? That's about, okay, so what I'm doing is I'm kind of drawing lines in my mind. There's my right angle right there, and I've got tool clearance, okay? And I'm gonna bring this up closer so you can see. So I'm gonna be turning now, okay? And so you can see I've got some tool clearance, right? Okay? So I've got kind of like relief. I know. All right. And what I wanna do is, it's not important exactly how far I turn, but I definitely want to turn more than the part, okay? So we can see here, I'm just gonna do like 2 1/8. All right, and then I'll be able to part it off. I'll be able to get the bore in all the way. Okay, so what I'm gonna do is I'm gonna line this up. It's not critical, about 2 1/8. And what I'm gonna do is I'm gonna put in what's called a witness. All right, so check this out. So there's my witness line, all right? Now I know where to stop, okay? And I need to adjust this a little bit more. Right about there, yeah, that's good. Now I know where to stop, so I'll just touch off again. Okay? I'm gonna take about 20 thousandths and see how that does. I'm going the wrong way, so I'm gonna adjust the... So there's my witness line. Now that's where I stopped. Okay? So that cut pretty good. Okay, that's for roughing, so that's pretty good. What we need to do is take a measurement because we need to be at 2.5 inches. So we are currently at, let's see here, just a little over 2.75. So I'm gonna go ahead and on the dial here, I'm gonna take, oh, I don't know, there's 10, 20, I'm gonna take 30 thousandths and see how that does. Was that? No. 20. I'm gonna touch off again. All right. So I'm at 20. There's 20. I'll take a 40 thousandths. Sorry, I had my math wrong. And we'll measure again here. Okay, so yeah, I was doing, okay, let's see here. So let's see, 26. I'm gonna do 26 thousandths on the dial because I wanna make sure that this is a brand new lathe to me. So I'm sort of feeling it out as we go along. So I moved 26,000. And what I'm doing, you guys, is, like I said, this is a brand new lathe to me. I've only put about an hour on it, all right? And I want to make sure that what I do on the dial corresponds accurately with what's going on the part. Okay, so that should put me get a good measurement here, right around 2.7. okay, and I mean really close to 2.7. So let's see how that does. I'm gonna slow it down a little bit. The feed rate, that is. Let's see what we got. So these chips are really sharp. Even with aluminum they are, but especially with steel. These bird's nesty types of chips. I'll talk about chip breaking later. I just want you guys to see turning and facing and a little bit of boring. Okay. All right. So there's that. Get this out of here. Be real careful with those. That's okay. It could be better. Could be better. So yeah, that put me right there. I'm about a half a thou out off the dial calipers. So I got to about 200 thousandths left, okay? So I'm gonna just do a pass at 50 thousandths. So remember, I had 200 roughly, and now I just took 50. Let's do another 50. All right. So let's see here. We should be around 2.6, right? We are. So the lathe is pretty good. I've got a little bit of getting used to it, I think. It's taking off a little bit more, so I'm 3 thousandths under that. So that's about right. Let's go ahead and let's take, how about 47? And let's do 47 thousandths, and that should bring us right at the 50. So let's see here. There's 10, 20, 30, 40, 7 thousandths. Let's see if that brings us to the Let's see. It did. It's spot on. All right, right to that marker. Okay, so I have 50 thousandths left to cut. I have to get to 2.5. Okay, so it's the lathe is spot on, which is really good news. What I'm going to do is I'm going to do 2 passes at 25 because I'm going to experiment with my finish pass. So I'm going to go ahead and speed it up, actually, even faster, I think. And because I got carbide, and so I have it on a very slow feed rate, and I'm going to take 25 thousandths. Okay. Let's see where we're at. Yeah, it's not great, but it's not terrible. 4 thousandths away. right there. It's okay. All right, so we're pretty spot on. 2.5, pretty much on the money there. What I'm gonna do now is I'm gonna see if this knurling tool fits in here. I gotta get rid of some of this. You guys gotta be real careful with these. They're really sharp. So this is a knurling tool, okay? And the way that it works is it has these two wheels here, okay? They're gonna go onto the material like this. And then this pivots like this, okay? So what we want is for this pivot point to be pretty center. It doesn't have to be perfect because, see, remember it moves a little bit, okay? But we want it to be pretty good. This particular knurler has 3 different courses on it. So this is a coarse knurl, this is a fine knurl, and this is a medium knurl. So we're gonna use the coarse knurl, okay? And pop this in here like that. All right, we've got some setup to do. And what I'm gonna do is we're just going to eyeball this, actually. And so I'm a little bit low, all right? So we'll take our wrench. I think I've got the wrong wrench. It's this one. And I'm gonna raise this up. A bit more. All right. Yeah, that was pretty good. I just eyeballed it, all right? And then what I'm going to do is I'm going to make this face flat on my the face of my part, so I know that I've got a pretty relatively perpendicular tool, okay? All right. And I'm gonna put this more in the rest, okay. All right, snug this up. All right, and now I want to make sure, very important, that this knurling tool clears everything that I want to do, that I'm going to get 1.75 inches of knurl. Definitely, okay? And now I got to adjust my feeds and my speeds. Okay. So on knurling, I typically run slow. I know there's some different schools of thought about that, but I do. And let's see here. And then what I'm gonna do is I'm just gonna turn it on and I'm gonna see what this looks like, okay? And so there's my power feed, way too slow. And I like that. So I'm gonna speed it up a little bit. So I'm gonna speed this up about 200 RPM. Okay. And yeah, that's good. Now, when you're knurling, when you make contact with this, you're committed. I can't take the tool off because I'll never be able to find the track, right? It'll lose the diamond pattern, all right? Also, real quick, knurling is a forming operation, so it's actually gonna make the part grow a little bit, which is fine. And so what I'm gonna do is I'm going to put this and make contact, okay? That's all I've done. I've made contact right there to the edge, all right? And I'll go ahead and turn the machine on. Okay, and now I'm just gonna give it a little bit of pressure. Not a whole lot, but some. And I'm gonna give it some, I'm gonna put some oil on here. Okay, and I'm gonna go ahead and engage the power feed. We're knurling. I got my hand on the power feed lever because I want to make sure to stop it. Right there. Okay. Now when I turn off the machine, got a messed up knurl again. There might be something wrong with my knurler. Okay. And then what I'm gonna do is I'm gonna reverse the power feed. A little bit more oil. Some pressure. It's all right. I'm gonna hit this one more time. I'm gonna slow this down. Let's see if that makes a difference. All right. Okay, so I got my knurl. I can back off the tool now. All right. And there's the knurl. So that turned out pretty good. I had some problems. I think that there might be something wrong with the knurler. I'll have to inspect it later, but that's beyond the scope of this class. Okay, so I got it to sit in there. You can see it's a little tweaked right there, but that's pretty good. Okay, so we've got this faced. We got it turned to diameter. We got it knurled, and now what we need to do is I've got to move this in the 4-jaw chuck over 100 thousandths. How are we going to do that? Well, I got a couple ideas. And what we're going to do first is I am going to get this in neutral. And I want to make the chuck pretty trued up, okay? And I put the badge up top so I know where I'm at, all right? And then what I'm gonna do is I'm just gonna pop this in low gear. See, now it won't move, okay? And then I'm gonna take my indicator here. And I wanna move that center, right? I'm gonna move that center over 100 thousandths. All right, so gonna get that relatively. Okay, I'm gonna preload that to 0. Wait a minute, hang on, let's think for a minute. I need a new indicator. All right. Let's do it this way. Let's preload this to 0, okay? And then one more time around. So that's 0 plus 100 thousandths, all right? And then what we will do is we're gonna loosen up this side here. And we're gonna move this over, hopefully, 100 thousandths. A little tight. get that yet? No. Yeah. Okay. It's over. Right there. And now let's see our look here. Bring the tailstock over. Badge up. You can see how it's not in there, right? Okay. Put a little divot there. Grab my calipers. Make this say 100 thousandths, roughly. And off of the center, we're there. Okay, so now let's give this a spin. I'm gonna put it at 194. Let's see how this looks. All right. We'll try it. Okay. I'm gonna take a quick break. Okay, so this is the tailstock. It can hold a variety of things inside. This is called the ram. Okay, you don't have to worry about that. This is a live center, and the reason it's called a live center is because it spins. Okay, and so that's because it spins. It's considered live. If it didn't spin, it would be dead. The other thing that the tailstock can hold is a drill bit chuck, or just a drill bit here. Now, what's going on is this is called a Morse taper. I'm not going to get into it right now, okay? But it drops in here, and the taper is really what holds it together. I'm going to put a center drill in the chuck. Just a drill chuck, okay? And we are going to see how my setup looks here. Okay, so I'm gonna bring this over. Notice that there's no tool in the holder, okay? And I'm gonna run that at about 260. And let's see what we can do here. I'm gonna lock the tailstock down here with this so it won't move, and then I'll feed it in here. Okay, yeah, it looks pretty good. A little oil, cutting oil. Okay, so there's our center. And now I'm going to put a pilot drill in here. Okay. And we're going to drill in here. Let's see. Start. We're gonna go about 2 inches, all right? And yeah, that's running pretty good. All right. A little cutting oil. Okay. The way that I am going to judge 2 inches is there's a scale on this ram right here. And it's not precise at all. But I don't need it to be precise. I just need to know roughly 2 inches. So I put it at 1 inch. I brought the drill up to the face. I'll tighten the tailstock down, okay? And a little cutting oil. And now, when I go to 3 inches, I will know that I've gone roughly 2 inches deep. There we are. So that's about 2 inches. Okay, now take this out. And let's get this chuck out of here. And what I'm going to do now is I'm going to put this 1 1/16 inch drill bit in here. I need this is a Morse, I think it's a number 3. So I need an adapter, okay? So that's all that this is, just a little adapter. Just fits in there like that. Okay. And same kind of thing here. I'm just gonna get a little oil going. I think I'm gonna drop the speed down. Remember, bigger the drill bit, slower we go. Okay, so see how that sounds. Oops. That's doing pretty good. Whoa. Might have fallen out of gear there. Yeah, I did. Okay. A little more oil going. Almost there. Okay, 2 inches. Back this out. All right. Turn off the lathe. I'm gonna grab my brush here. A brush. And these are hot and they're sharp. So we're gonna get rid of these. Down in the bucket. So some room. All right. Okay. Now, our non-concentric hole. Okay, so now what we're gonna do is bore this out to 1 3/8, and I'm going to use. I think I'm going to use this. See how this performs. So this is a boring bar, okay? And okay, so I can tell I'm low. And it's the same thing as turning, sort of, except it's inside. It's inside the hole, okay? And I'm gonna raise this up because I'm really low. Oh, that's right, I need a longer pin. So I'm gonna do what you shouldn't do. Let's see. A little bit higher. Wonder if I'll clear. Yeah. All right. So same kind of thing. Okay. I'm going to use the depth gauge that we made. All right. And yeah, that'll work right there. Okay. So I have the tool touching that. I'm going to zero this out. And okay. I'm going to zero this out. And I'm going to manually turn up the speed. I'm going to try 500. And touch off on the inside. Okay. And then take a little, I'm going to do this manually. So there's 0. I'm at the face. And yeah, and I can watch the dial here. Make sure I'm not rubbing. I'm not. All right. So there's 100. No, I'm good. Rub. I know it's weird with the part all seeming like it's going haywire, but it's not. You can see the inside. Okay, so there's an inch, right? See that? There's 0, that's the face, all right? 100, 200, etc. Let's go back in. And then there's 1 inch. Now, even though I have a 2-inch throw on here, I'm still gonna reset this, okay? Just trust me, all right. And there's 200. Okay, there's 2 inches. Now, I just do this because it's easier for me to read. So what I'm going to do is I'm going to preload this and put it on 0. So I have 100 thou. Okay. Okay. Now, what I'm going to do is I'm going to start using the power feed. Now I'm going the wrong way, so we'll flip that, and that looks pretty good. And I'm just going to take, oh, I don't know, let's do 40 thousandths. Okay, and let's see how that, too fast. Slow this down. Did I lose my, yeah, it didn't like that. I did. I lost it. It's okay. Slow it down. Let's see how that behaves. Yeah. Okay. Clear those chips out of the way. That was a little bit aggressive, so I'm only going to do half of that, or maybe I'll do 30 instead of 40. Let's see how that how that perform. Yeah, that's a little nicer. All right. Well, okay. You guys. All right. Let's measure and inspect. Looks pretty good. Yeah. All right. So let's. Yeah, still not the smaller, but I still have such a far ways to go. Okay. I'm at roughly 1.2. Remember, this is not how to measure. I'm just getting a very rough. Okay. So I got 100 thou to go, and then I'll be able to get the gauge in. 30. All right. So it's pretty good. That's pretty good. Let's measure. So here we go. We can measure. Put this in here. Tighten the screw. It's at an angle, and then I'm just going to draw it through like that, right? And then I can take. I'm roughing. Remember, I'll use the micrometers. Okay, so I'm at 1 inch and 308 thousandths. All right. So what? I need to go to 75. So let's just do another 30, and then we'll measure again. Okay. So there's 10, 30. All right. And let's measure. Okay. Right about there. And 136, 137. Let's see what the chronometers say. 25. Yeah, 136 on the mics too. Okay. So, right, so we are here, okay? 131 inch, 336 thousandths, okay? So, if I do, let's say 14, if I do another 30, I'll still be safe. So let's do another 30. Actually, I changed my mind. Let's do 25. So there's 25 on the dial. Okay. Go ahead and take this cut. All right. All right. It's okay. That'll work. And let's see what this has to say. Yeah, that was a good pull. Okay. 150 plus 14 is 64. Okay, so just so you have a visual what that's like. 164. So I need to do 11 thousandths. So I'm going to go ahead and this will be it. So there's 10 and 11 thousandths. All right. Okay. Yeah, that's nice. Okay. And pull that through like that. Let's see where we are. So that we want that to line up with a 0. Oh yeah, right there. Okay. So we are exactly 1.375. Just so you guys can see a little better. I mean, we're spot on. Okay, we are spot on 1.375. Okay. We'll go ahead and move this out of the way. So we are nearly done here. What I'm gonna do now is I'm gonna part this off, and I'm gonna use the parting tool for that. Let's see if I range in there. Yeah, I do. Okay. And what I'm gonna do is put this in here. Okay. And what I want to do on the parting tool is I want to run the parting tool a little bit positive, and I can tell that I'm high. So this is cooled off. Let's get a rag. Clean the chips off the drill bit. You don't want to leave the drill bit in there like I did, because if you bump it with your arm or something, you can cut yourself. But it was too hot for me to really move, so I just got it out of the way. So we'll take the drill bit out. I'm gonna put the center back in, okay? And I'm going to see about setting up this parting tool. And I just realized that I'm gonna need to bandsaw it off because it's not concentric. Okay. So, shoot, I wanted to show you parting. What's gonna end up happening is I'm gonna get through. I was gonna put a groove in here, okay, and with a parting tool, and I'd get through to this much, but then there'd be that much left over, right? Because I'm on the outside diameter now. And so what I'm gonna have to do is I'm gonna have to bandsaw this off, put it back in the lathe, and then face it. Nice and slow. I'm just going to lightly deburr this. Yeah. Okay. All right. Next, this will be relatively quick. Let's see here. This oily. That's good. So let's put this in here, and you'll see what I'm up to in just a moment. All right, let's see how that's running. Where's my speed at? Let's do 350. it's running pretty good. Not perfect, but it's running pretty good. Good enough. So, all right. What I'm gonna do, I'm gonna pull that out just a little bit more, just a little bit. It's a little close, even for me. Let's see how that's. Yeah, that's not so good. There we go. There. Yeah. Let's try this again here. See it crooked. All right. Yeah. That's pretty good. All right, so I'm gonna use a file, and on the lathe, it's okay, but what you got to do is you've got to use the file left-handed. So I'm gonna see this. Okay, you can't do that. All right, I know that's what you naturally want to do, but you can't. And I'm not pushing. Okay, I'm letting the file do a lot of the work. And all I'm doing is removing and rounding this edge. And look at that. That looks pretty good. I'm just gonna hit it a little tiny bit more here. All right. That's pretty good. Okay, now let's take this out and put it back in. And I'm gonna face it. Okay. And so let's use just use this. This will work. High-speed steel. And cut with the tip. And this tool wants to cut this direction. So bring this up here. And here are my calipers. Let's take, it doesn't need to be exactly 1.75. It just needs to be relatively close, within a few thousand. So this says 1.830. So, right, I have to go 80 thousandths. So let's go ahead and, okay, feeds and speeds are set right. Let's go ahead and, whoops. Let's just take a quick zero cut here. I'm gonna zero this out. All right. Okay. Let's see. That was a, let's take one more. Yeah, I see what happened. All right. So what we're gonna have to do is lock the carriage. I'm gonna lock the carriage. so I don't get any deflection or movement from the carriage, okay? And let's see what we got now. I got a 0, so I can move. Okay. So it looks like we've got about 63 thousandths left. So I'm just gonna do 60, okay? Like, it doesn't need to be perfect. So, right, we've got our 0, okay? We're all zeroed out here. There's 25. Lock the carriage. There's 25. Okay. Unlock the carriage. There's 50. All right. Huh? Not too shabby, not great. What I'm gonna do is I'm gonna speed it up, and I'm gonna take that last 10 thousandths slow. So there's 60. Lock the carriage. And yeah, that'll work. Okay. And do now, same thing I did before. I'm gonna bring this part out. Tricky with the knurl. Take the tool out. All right. And I'll drop this down. Try that. Let's see if that's any better. Yeah, there we go. Got it. All right. Left-handed. You guys, that's real important. Okay. A couple other little cool things I can do, and I'm going to do it. So I'm going to take, I'm going to use this. Here's a little 45-degree tool. And what I'm going to do is chamfer these edges. Okay. Get my gauge out of the way. And just touch this. Just a little. I'm actually going to raise the tool up a little. Right there, okay? And let's flip it around. Why soft jaws are so cool. And we'll do the other side. Right there. Right there. And you're out. Okay. And then I'm going to put the bandsaw into high. It was in low. Ow. So the bandsaw is in high. And now I've got a 3-corner file here, and I can file out these burrs. Okay. That slit. Now this isn't going to fit just yet. Remember that? So I finished this, okay? This isn't going to fit. I'm actually pretty positive it won't. Let's try it. Yeah. So the reason it doesn't fit is because when I cut this slot, right, it collapsed on itself, which is kind of what I wanted it to do. So in order for it to fit, what I'm going to do is, well, let's just do it. Jeez. I wonder if this will work. Yeah, this might even work. Let's get the screw out of here. Is that... hang on. Yeah, I even got the right. Okay. I'm gonna put this plate in there, okay? And, no, I gotta get a different screw. All right, there we go. It's got a longer screw. So check this out. What I'm gonna do is I'm just gonna split this. Get this. Open a little bit. Now this will just drop right in here. Okay, and okay, there's that. Let's undo this screw. Pull this out. If we can. Hung up on something. Maybe a burr or something. There we go. Okay. So there you have it. Okay. And that looks like that's pretty good. Let's see what our bore's like. So it collapsed just a little bit. It looks like it collapsed 6 or 7 thousandths. Let's get another. Okay. Yeah, so it looks like it collapsed. I'll take it from a different spot. And that's actually good. Remember how I was going to machine it 120 instead of 125? I was sort of thinking on the fly. I'm glad I didn't. Yeah, so, okay, so it collapsed about, there's 5 thousandths, it collapsed there. If I turn it to this position, I can already feel it collapsed a little bit more in the middle. Okay, let's see what that says. Ooh, 8 thousandths. Let's move it over here. This position. Let's see what that says. 7. So that'll lap out. What I mean is, well, I know we haven't even talked about it yet, but that will lap out. So there's our tool for lapping OD of a. I gotta clean it up. We don't have any air right now, and so but looks pretty good if you ask me. That's pretty cool. And then this screw goes in here, and as this aluminum wears out, actually I shouldn't say wears out, as it gets bigger from lapping, we can tighten this screw and this will close. Okay, so here we are. Cool.